Good morning, everyone. Good morning. Yes, Priyadarshini. Hello. Good morning. So yes, in this video we'll be discussing all these things. Fine. 20 questions MCQ, 5 MSQ, and 5 NAT type questions for solid state chemistry. That is present in your IIT JAM syllabus. Okay. Yes, Winson. Good morning. So I will be starting within 30 seconds. Fine. I will be starting within 30 seconds and I will be solving a lot of problems regarding this. Yes, Shibras, hello. Yes, Milan, good morning. So, have you read this chapter? Please do let me know first. Please do let me know. Have you read this chapter? Have you read this chapter? Yes or no? Okay, this chapter is very small chapter. Okay, very small chapter is this. So yes. Okay, but not completely. Okay, then great. So okay, I'm starting then. Fine. So it will take more or less 30 minutes or 35 minutes live session, but in this live session I'll be showing you different types of questions that you can face in your IIT JAM examination. Fine. So first question I am asking is this: which of the following is correct dimensional features of orthorhombic unit cell? You have 20 seconds to answer, then I will be telling you the correct one. So you know the table, right? For orthorhombic, for cubic, for monoclinic, for other tetragonal, for trigonal, right? For hexagonal, you know everything. The total 7 crystal systems are there. So out of the 7 crystal system, I asked you about the orthorhombic crystal cell, orthorhombic unit cell. So which of the following option belongs to that orthorhombic unit cell? You have 10 seconds more to answer. A, B, C, D. Which one? Answer first. You have only 10 seconds. 5, 4, 3, 2, 1, 0. Okay, 10 more seconds. Okay, awesome, very good job. Okay, so this is purely this question is purely memory based question, so you have to remember, and you have to remember the structure of orthorhombic cell. Okay, actually for orthorhombic cell what happens, alpha, beta, gamma, all these angles becomes 90 degree, but this A, B, C, they are not equal. I mean A, B and C, they are not equal, but this angle, all these angle becomes 90 degrees. So option D is the correct option. Perfect. Going to the next question. Question number 2. Which will be the mirror indices of which indices? This one. So I have given you which indices. You have to get the mirror indices. You have 4 options. You have 4 different options. Which one is the correct one? Which one is the correct one? Which one is the correct one? Anybody? Which one is the correct one? Ten seconds. So 1 2 0 2 1 0 0 1 2, like 1 1 by 2 0. Okay, 10 seconds more. Prayojit, Dasgupta, Milan. Okay, awesome, very good. Yes, the correct option is 1 2 0. How can you get it? So you have 2 1 0. Which indices? Do one thing: 1 by 2, 1 by 1, infinity by 1 by infinity. So you just need to take the reciprocals of these Weiss indices. Once you take the reciprocal, you will be getting the Miller indices simply. So 1 by 2. Okay, so this is not a whole number, so you have to make it whole number. So what you can do, this means actually 1 by 2. This is actually 1, it is 0. So multiply with 2, so it will become 2. It will become 1, it will become 2, it will become 0. 1 2 0. That's how A is the correct answer. Very good. Yes, Arnab SK. Good job. Next question. The vacancy in Fcc Lattice. So this, if you can't calculate, if you don't know the vacancy, then you have to calculate it in the exam hall. But I would recommend you that please do remember the vacancies of Fcc, BCC, and simple cubic. These three packing efficiency you have to remember. So what will be the answer? The vacancy in the Fcc Lattice. You have 20 seconds. So if you have read this chapter is too easy. Believe me, this chapter is the very easy chapter. Okay, very easy chapter this is. Fine. So some of you are saying, okay, Shibraz, awesome, good job. The correct answer is C. So don't think it is packing efficiency. It is not PE. It is not packing efficiency. It is, I am talking about vacancy. So you may do mistake in understanding the question, right? You may do mistake. So it's about vacancy, not the packing efficiency. Packing efficiency is 74%. A. Vacancy will be 26%. So option C is the correct one. Good job. Next question. What will be the bond exponent value for Kcl? Yes. Good. Yes, Shibras. What will be the bond exponent value of Kcl? Okay. Just solve this question. Bond exponent, that you know, in the bond length equation, bond exponent is represented through n. What will be the bond exponent value, n value for Kcl? How can you calculate this? All these things I taught you in my solid state lecture. All these things. You have 10 seconds more. You have 5 seconds. Okay, 10 more seconds. Anybody? Any answer I can expect? Nothing. Okay, so it's very simple. So you just need to remember this table. Whatever table you can see, you just need to remember this table. Look at this. Okay, some of you are giving me answer SK. SK is giving me answer 9. It's awesome, good. Option C will be the correct one. Okay, so the logic is very simple. Remember, for bond exponent value for helium, neon, argon, krypton, xenon, you need to remember this table. Simply, just all these noble gases, bond exponent value. These values are actually bond exponent value, and these are the noble gases. Okay, so for helium means not only helium. Helium means for helium electronic configuration. Neon electronic configuration, its electronic configuration, this electronic configuration, this electronic configuration. Fine. So it's about Kcl. If you break Kcl, you will be getting K plus and Cl minus. K plus has electronic configuration of what? Argon. 9. Great. Cl minus, argon. Then you have to take the average. 9 plus 9 divided by 2. 9. Argon's electronic configuration. So what you need to do? You just need to take the average value. And these are actually noble gases electronic configuration. So for helium electronic configuration, this, neon, this, argon, this, krypton, this, xenon, this. Remember in this way, 5, 7, 9, 10, 12. 5, 7, 9, 10, 12. 5, 7, 9, 10, 12. Remember this one, okay? These are the values for bond exponent. Great. Look at this. That's how we are getting 9 values. So at the end of the day, you have to take the average of these two values. Okay. Next one. Okay, so first of all, look at this option, look at this picture, and be careful. Whenever you are answering this question, please be careful. So I am asking, this plane that I have drawn, I have shown in this picture, this plane belongs to which one? This plane belongs to which one? So a lot of confusions are there, but I am recommending you to take this axis as your x-axis, then other axis as your y-axis, these axis as your z-axis. I will be recommending you to take that. If you change your axis, you will be getting different plane. Okay, so please do it. So Prashant is asking, what is the bond exponent value for MgSO4? So I can't say that. SO4 2 minus, I can't say that. I have to take the experimental value for that. I don't know that SO4 2 minus has what is this element? It is not an element. It is not one element, okay. And especially remember, this bond exponent like things, is purely applicable for ionic compounds, not covalent compounds. And Mg, in case of MgSO4, because of the Mg means Mg2 plus, SO4 means SO4 2 minus, because of the size of the SO4 2 minus, a lot of polarization happens, and because of that polarization, what happens? The compound becomes covalent. It is not ionic compound, so you cannot apply bond length equation over here accurately. Bond length equation you cannot like apply here. So I don't know the value of this. So that I have to do. If I want to calculate it, then I have to measure experimentally. But I think in this case, bond exponent value, nobody will ask you. Even like in most of the cases, you have to ignore it. Okay, because this compound becomes little bit gets covalency because of the polarization of the SO4 2 minus. That's the reason. This bond exponent belongs to bond length equation, and bond length equation belongs to ionic compounds, not covalent compounds. Got it? Next question. Which plane? You have 4 options: 102 to 200, 120, 110. Which option? You have 10 seconds. You have 10 seconds to answer this question. You have 10 seconds to answer this question. Okay. Okay, you are saying option A. Prashant, let's see. Option A. So this x-axis 1, very good. Y-axis, it is parallel to y-axis 0, very good. Awesome. Good job, Prashant. Yes, correct option is option A. Good. Okay. And some of you are saying option C. That's why I told you. If you say option C, and if I give you another option that like 0, 1, 2, that then also you can't ignore this option. So that's why I told you, please be careful whenever you are having these kinds of problem. Suppose in your examination you are having both of these option and this option. SK, I am not saying that you are wrong. I am not saying you, but I am telling you that if you face this kind of problem in your examination, you don't need to do this kind of mistakes. Okay, because this is correct. I told you, you have to take these axes as your x-axis, this y-axis, and this z-axis, because this is the like we generally take the planar axis as x and y-axis, and that one as my z-axis. Okay, we generally take this. And if you take this one as your x-axis, there is nothing wrong in it. You can take this one as your x-axis. Even sometimes you can take this one as your y-axis, or this one as x-axis, or sometimes it is x, it is y. You can take that. So in that case, this option and this option, both of them will be correct. But according to you, you are saying 120. 120 means x-axis 1. So x-axis 1 means this is x. This is x, then 2. This is y. This is z. So whatever axis you are choosing, based on that you will be getting your answer. But remember, if you consider a plane, you generally consider x and y axis. You say x and y plane, right? So whenever you are getting this kind of confusing questions, that's why I have given this question. Whenever you are getting these kinds of confusing questions, please remember, consider your planar axis as your x-axis, x and y-axis, and then the vertical one as your z-axis. I am not saying you are wrong, but I am just telling you that don't, like in your examination, if you face this kind of problem, please choose in this way. Got it? Next question. This one. For the NaCl, the lattice parameter is given 564 picometer. What will be the density? So I am giving you the formula. Density equals to total mass divided by total volume. Charu. Okay, Charu, you haven't answered the last question, right? So come back. Question number 6. Which will be the correct one? Anybody? Anybody can tell me? Anybody? You have 20 seconds. Okay, you have 30 seconds. Okay, because this is a numerical type question, so you need time. You have to use calculator. Okay, you have 30 seconds. I am giving you, and you can do this. I know you can do this. You can solve this question, because I am not going to solve this question because it's a numerical type questions. I will be telling you how to solve, and I will be giving you the answer. Then you will be choosing your answer. And from this chapter, once again I am telling you, very easy type questions you will be getting, very easy questions. Okay, and whatever formula I am using, all this based upon these formulas you will be having questions. Actually a lot of other problems are there in full mock test, but in these mock test You won't have like, you will be having 30 questions of different kinds. Okay, Prayojit, awesome, good job Prayojit, good job. Option B is the correct one, 2.16 gram per cc. So suppose why I have written this kinds of thing. So I am asking you to calculate density, simply density, right? So density means mass by volume, you know. So I am writing total mass and total volumes because we are dealing with lattice, and we are dealing with NaCl lattice. Fine. So for a particular lattice, what happens? How can I calculate total mass? So simply that Na number of atoms, Na number of particles have mass, capital M, molar mass, and in this Fcc lattice, or NaCl is the NaCl shows Fcc lattice. Fcc means what? Number of atoms in the unit cell is 4. So 4 lattice will have how much? 4m by Na. That is the total mass you have got. Total mass. This value is total mass value. What is the total volume? So Fcc lattice means this is my total unit cell, right? The total volume of the unit cell is what? Side length is A, so it will be A cube. So you know the total mass, put it. Total volume, put it. I have given you, it is NaCl. Okay, so you know the value of M, total molar mass. You know the value of Na, Avogadro number. You know the value of 4, and total volume will be A cube. So exact formula is this: D equals to N or small n, capital M, Na, A cube. This is the formula. Okay, this is the general formula. N is the number of atoms in the unit cell, or number of lattice points in the unit cell. M is the molar mass of the system. Na is the Avogadro number. A is the side length, this side length of the cube. Yeah. So this is how, using this formula, in this case I have shown you how I am getting this formula. Simply put the value. This 4 is actually this small n value. So put the value of total mass, put the value of volume. You will be putting it, you will be getting the density. So if you forget this equation, like what is the density equation in your examination, you can directly calculate by using this equation. Even I generally forget these expressions. So I thought, if I forget, definitely I can show my students that how they can remember without remembering these expressions. You know, density means mass by volume. Mass you will be getting in this way, volume you know, put it, you will be getting your formula. Put it, all these values, it is in picometer. So convert this value from picometer to like centimeter. Once you convert this value from picometer to centimeter, you will be getting your answer, this one, 2.16 gram per cc. Okay, great. Next, question number 7, the number of Bravis lattice. Okay, this is very simple questions. Just you have 10 seconds to answer. You have 10 seconds to answer. Till then I am getting one comment from Prashant. Prashant, Frankel defects is not in your JAM syllabus. Okay, Frankel defect is not in your JAM syllabus, and you can think that why I am giving you this kind of question. If you check the previous year question papers, this question has already came. This question has already come. Okay, so don't think that from here you will be getting very complicated questions only. No, you will be getting very easy questions as well. Next question, question number 8. Let's solve this question. Okay, I hope you can see this question. Yes, can you see this? In a CCP lattice, the total number of particles is X, total number of tetrahedral and octahedral holes are Y and Z. Then what is the relation between X and Y and Z? Divayat, listen one thing, if you don't understand English, so problem will happen what? Because I can continue this video in English, but the thing is, if I continue, then most of the students won't understand that. Okay, because a lot of other students are there, a lot of South Indian students are there, so that's the reason. Okay, so and another thing is that this video I am actually recording for those students, for Hindi and English students, so I can't like make in Hindi. But if you want to like get Hindi videos, then you have to like check my Benjin batch, okay, where both English and Hindi videos are there. But for the time being, I can't make videos in Hindi because then I have to make 2 videos for them. I can't do that. Okay, please try to understand, and if you don't understand English, then there is nothing to do like with MSc. Why you are like doing MSc, right? So you know this, take it positively and start doing this, because in future whenever you will be understanding anything, all the professors, all the teachers, everybody will teach you in English, so you have to be familiar with English, right? Even my English isn't good, even I didn't know English, but The thing is, I had to learn and you have to understand as well. Okay, great. Next question. Okay, so I am getting comment Prashant and Prajit. Okay, so yes, you are absolutely right. Option D will be correct option. Okay, option D will be correct. Option D. Why is that? Listen, it's very important thing. So total number of particle is X. Remember, total number of particle in the CCP lattice cubic closed packing lattice is X. And for X lattice, you generally get, for CCP X number of particles, you generally get X number of octahedral hole and twice the number of 2x number of like tetrahedral holes. Okay, that means if here it is given that octahedral hole is given by Z. So I have already given that octahedral holes means Z and tetrahedral hole means Y. Right, now try to correlate X and Z, they will be same. So X and Z, they will be same, yes, but Y is actually 2x equals to Y. Okay, so if I represent Y, so Y will be what? Y will be like X will be Y by 2, right? So that's why like X equals to Y divided by 2 equals to Z. Simply just apply your normal mathematics, you will be getting it. So for X lattice points, for CCP lattice, for X lattice point, you will be getting X number of octahedral hole and 2x number of tetrahedral holes. Remember, double the number of tetrahedral holes. So from X, you will be getting X. From X, you will be getting 2x. Now I have given you this value is Z, this value is Y. So definitely, from here, if you want to calculate X, if you want to make equal with X will be what? Y divided by 2. Bring this 2 over here. So X equals to Y by 2 equals to Z. Simply, okay, this question is interesting question. Next question. If you don't understand this, please do ask me. Next question. A crystal solid is made of ABC elements form a cubic lattice. Remember, form a cubic lattice, okay? If A, B, C atoms stay in the corner point, so A in the corner, B in the body center, I mean body, C is the, look at the center of the edges, A center. So A is present at the corner, B is present, B present at the body center, C present at the edge of each corner, edge center of each, okay, center of each edge. So first of all, draw a picture, draw a simple picture. In this picture, if I show you, okay, first of all, I am giving you the chance to answer. ABC3, Arnab is saying ABC3, ABC3, Arnab, Prajit, Pritham, okay, SK, good job, yes, the answer will be ABC3. How? Look at this, simple, A is there in this way, at this corner. So how many A is there total? How many A is there? 8A, and from corner we get 1 by 8 part, 1 by 8 multiplied by 8 lattice, that is total number of lattice 1. For A is done. Now B, body center means over here. So another lattice that is present over here. So at this position you will be getting 1 multiplied by 1, that is giving you 1. Simply, so you are getting 2. Third of all, C at the edge center. Edge, how many edges are there? 12 edges are there. Good. So 12 edges means here, 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 here. So now tell me, in these unit cell, from a particular lattice point that is present at the edge center, how much you are getting into the cell? How much? So how can you understand that? How much? Like here 1 by 8 I am telling you. So how do you understand that 1 by 8 is there? I am telling you, from the edge you will be getting 1/4. How? It's very simple. Look at this. Here at this position, how many similar kinds of cube you can put that can touch this edge? Just think, with this edge, on this edge, how many same lattice, same size lattice, I mean this unit cell you can put that will touch this edge? 4. How? over here one, like over here, then in the below side another, then this is another already present, and in this side another. So at this, with this edge, you can attach 4 lattice 4 unit cells. So that means 1 unit cell will get 1/4 part for from a particular lattice point. That's why I am getting 1/4. And there are 12 edges. So from 1 edges I am getting 1/4 part. From 12 edges and 12 lattice points, how many I will be getting? 1/4 multiplied by 12. That is giving you 3. Right? That is giving you 3. So 3, 4, 5. There are total 5 lattice points. Check. 7 lattice points. 6 lattice points. 6 lattice points. 5 lattice points. Simply. Very simple answer. Okay, next question. The coordination number of Cstl. This question actually came in IIT JAM examination already. So don't think this question is too easy. As I already told you, I will be giving you those questions which are like related to IIT JAM examination. Okay, so this question already came in IIT JAM examination. So you can think that these kinds of very easy questions you can follow. Devajit, Divyat, I'm sorry if I am taking any if I doing any mistake. Pritham, Prayajit, Shibraz, very good. Okay, so your option will be option A, 8:8. Okay, and next question. This question, how many of you can solve this question? Let's see. Question number 11. So I am giving you in the orthorhombic cell, orthorhombic crystal. Orthorhombic crystal means what? Again I am making you remember. Orthorhombic crystal means A not equal to B not equal to C, but alpha equals to beta equals to gamma. So in this case, which one will be the correct option? Like plane makes intercepts values are given. Corresponding primitives means do you know what? Primitives means, you can consider cell lengths, unit cells lengths, A value like these values, A value, B value, C value. These are called primitives. Okay, primitives are also given, intercepts are also given. You need to get the Miller indices. Okay, so just calculate. You have 30 seconds to calculate. I am giving you 30 seconds for that. Okay, 30 seconds. Let's see how many of you can solve this problem. It's too easy. It's a basic problem regarding Miller indices. If you understand Miller indices, you can solve it easily. If you don't understand Miller indices, then it will be a little bit tough for you. But yeah, I am explaining this question once you give me the answer. Anybody? Any answer I can expect? Can I expect? Question number 11. Any answer? Okay, I am giving you more 30 seconds because yeah, you have to do a lot of calculations. So I am giving you more 30 seconds. Let's do it. Okay, so let's solve. I am solving this. Fine. Nobody. Okay, great. So listen. How can you calculate Miller indices? So what is the definition of Miller indices? It's very simple. Miller indices basically means side length divided by intercept. Side length divided by intercept. So A, B, C, these are actually side lengths. I told you A, B, C side lengths. Intercepts will be represented through H prime, K prime and L prime. So here there are 4 options. Okay, so now you know the side length values. You know the ABC values. ABC values are these: 3.05, 6.99, 4.90. Okay, and you know the values corresponding H prime, K prime and L prime. First one belongs to A, I mean this one, second one is this, third one is this. Okay, so now let's solve this problem. Just put the value of A. So if you put it like A value 3.05 divided by 2.93, then 6.99 divided by 4.47, and finally 2.35 divided by 4.90. So these divided by this, these divided by this, finally these divided by this. So once you do this, let me calculate, because I don't know which is the correct one. Let me calculate these values. 3.05 divided by 2.93, you are getting 1.04. 1.04, that means I am writing 1. Okay, 1.04, great. Then 6.99 divided by 4.47, 1.56, and finally I am getting 2.35 divided by 4.9. Anything wrong? Okay, I'm sorry guys, I'm sorry. Actually I wrote it opposite. This divided by this, I have to write, yes, 4.90 divided by 2.35, sorry, 2.35, I'm sorry. So now put it, 4.9 divided by 2.35, it gives you 2.08. So make this whole number. It is 2, it is 1.5, it is 1. So if you multiply it by 2, what you will be getting? 2:3:4. This is your correct answer. SK, no, it's not. Option D is not correct. Simply option B is correct. Okay, that's your answer. It's very simple. Next one, anybody? Question number 12. Question number 12. In the primitive unit cell, the number of lattice points, you have 20 seconds. 4 primitive lattice points. Okay, anybody? In the primitive unit cell, the number of lattice points, anybody? 4. Okay, you are saying 4. Anybody? Four. Prayojit 1. Okay, so I am giving you, in case of primitive is nothing but, primitive means simple cubic. Prayojit is right, all other students are not. Primitive is basically simple cubic. Only at the corner you will be having, only at the corner. So at the corner means 1/8 multiplied by 8, that gives you 1. Okay, so if you have any issue you can ask me. That's primitive. This cell is called primitive. Where in this unit cell, in this cubic cell, in this cubic unit cell, at the corner only lattice points will be there. So corner means 1/8 multiplied by 8, you will be getting 1. That's all. Question number 13. So question number 13 has this part. Okay, so ignore this part. Tell me, what is that? Which one is the correct answer? Which one is the correct answer? In BCC structure, effective. Okay, this question is too easy. 2. Perfect. Good. Yes. Good job. Now, NaCl. Because, okay, these questions are not tough. I am telling you, these questions are just for practice. Okay, these questions are not tough, but this kind of question you may face in examination as well. So I am giving you very less number of this kind of question. All questions are like conceptual. If you cleared your concept, you can easily solve it. NaCl crystal, yes, definitely it is Fcc. All of you know this, so I am not going to discuss this one. Now this question, again, it's a conceptual question, but if you can visualize, you can do this easily. Good. Now come back. If A and R be respectively the lattice constant, radius of an atom in a SC simple cubic structure, then choose the correct option. So you have to focus on these words, simple cubic, and A and R be the lattice constant and the radius. So A is the lattice constant. So you know lattice constant means what? Do you know? Lattice constant is also called lattice parameter. Lattice constant is also called lattice parameters. Lattice parameter or lattice constant means, do you know what? Suppose it is your unit cell. So this lattice constant or lattice parameter, that means nothing but the side length. Side length that is represented through A. Okay. Side length that is represented through A. Now let me draw this picture more clearly. Okay, let me draw this picture. Otherwise I can't make you understand. Okay, so now let me put all these things. Lattice parameter. So I am talking of simple cubic means what? Here one lattice point, here another lattice point, here another, here another. But I cannot show you through this structure. I have to show you in this way. I have to show you in this way. Actually this is your A, I mean this value, and this is your another one, another. So this means this. Now these are the lattice points present on this plane. Now if it is true, then what will happen? This is your radius for this lattice point, this is your radius. Okay. So if it is true, then side length will be A. So A will be what? 2R. So here, yes, in the real question it is 2R, so it's not printed, so it will be 2R. Option B will be the correct one. Not option D. No. A will be 2R. So it's 2. I forgot to put R over here in the printed version, but in the actual question it's 2R. Dibayat, how can I contact with you? Check the description. You will be getting my application link and also WhatsApp number. You can contact me from there. Next one, the coordination number of simple cubic. Anybody? What is the coordination number of simple cubic structure? What is the coordination number? Okay, scan. Nothing to worry. Actually, in the actual question it's corrected, but in this I think it's like, so coordination number of simple cubic. Okay, you are guessing, right? Chemistry with A's. You are guessing, right? You are just saying that yes. Okay, Prayojit 6. Anybody else? SK 6. Very good. The coordination number of a simple cubic is actually 6, not 4. How is this possible? It's very simple concept. So if I draw this lattice point, simply you get this kind of thing. This is your simple cubic, right? So if you have, suppose this one, another cell. Suppose you have another cell. So this is actually this is present for in this way. This is the part of another unit cell, definitely. So if it is the part of another unit cell, so it has how many? Like 1, 2, 3, in this way. Like I can't show you in this way because in this picture, in one picture it's impossible to show you, but yes, I am trying. So from here you can have another picture, you can have another picture, another picture, another picture, another picture, like octahedral like things. Okay, octahedral like things. So it's tough with one picture. So just give me 1 second. Let me show you. Let me share my screen. Then it will be better. Okay, just let me show you. I have kept it ready. Okay, I have kept it ready. Just show. Let me show you. Just 1 second. Just one second. Yes, it's perfect. Just give me 30 seconds. Just. Okay, look at this. Now look at this problem. I am making this zoom. Okay, just look at this. Just look at this picture. If you look at this picture will show you that how the coordination number of simple cubic is 6. Fine. Just look at this. Look at this picture, you will be understanding everything. Okay, so just take a screenshot. You have time to see this. Now I am just removing this one. Okay, I hope you understood this thing. Fine. Now next question. Next question will be this. Question number 17. For NaCl crystal having lattice constant 5.6 Armstrong, the interatomic distance is what? The interatomic distance is what for NaCl crystal? How can you tell me? Can you give me the answer? Okay, escape. Good job. Actually, to understand this chapter, you have to have three-dimensional like visualization. If you don't have three-dimensional visualization, it will be very tough for you. Shortcut method will be working for some time. If you forget that shortcut method, and in your examination you will definitely forget that shortcut method if you don't practice. Okay, but if you understand, if you can visualize all the structures, then it will be far more better. Okay now? So now for NaCl crystal having lattice constant 5.6 Armstrong, the interatomic distance will be what? How many of you? You have 10 seconds to answer. You have 10 seconds to answer this question. You have 10 seconds to answer this question. 5 seconds. Anything? So again I am telling you, lattice constant means side length, lattice constant, lattice parameter, side length A is given. Okay, side length A is given. So do you want to try it? Okay, so I am explaining then. So look at this, lattice constant. Draw NaCl structure. You know NaCl shows Fcc lattice. Fcc means what? These kinds of lattice, right? So here you will be having 1, 2, 3, 4, 5, 6, 7, 8. And now here each at the corner of every, at the face of every like 6 face, you will be getting these kinds of lattice points. And if you now, if I now show you only this face, how it is looking like, only one face, if I now show you, it will be looking like this. This, then this, this and this, or just I am drawing bad picture. Okay, this and this. So these lattice point and these lattice point, they don't touch, but according to this corner they are touching each other. So simply this is one, so R, this, simply look at this. So lattice constant is given 5.6 Armstrong, right? Lattice constant means side A. It is given side A. Okay, so now what will be the length of this diagonal for Fcc? Okay, I think okay, just 1 second. I think we have wrong options in this question, right? Yes, lattice constant is like A. So this will be what? A root 2. A root 2 equals to 5.6. So A will be what? 5.6 divided by root 2, not 2. So if it is 2, it will be 2.8. So it's root 2. That means how much I am getting? Let me check. Let me do the calculation. 5.6 divided by 1.414. 3.96. Right? Okay, okay, I'm sorry, lattice constant. Okay, why I'm calculating A? Sorry, just 1 second, A will be this value. A root 2 will be, I'm sorry, just A root 2 is this, and this means R. So there will be 4R. Okay. So interatomic distance means from this distance to this distance. This is called interatomic distance, right? So if I calculate this interatomic distance, so what will be this? That means I need to calculate 2R. 2R will be equals to A root 2 divided by 2. Yes, that value I have to calculate. A by root 2. Okay, A by root 2. 5.6 root 2. Okay, what I am doing? Actually, I think option A is correct, but okay, just 1 second. 5.6 by 2 root 2. 5.6 by 2 root 2. 5.6 Armstrong is lattice constant is given. Okay, 5.6 is given. Okay, what I am doing, guys? Actually, I solved this problem. Where I am doing mistakes. Okay, so once again, the interatomic distance is what? Interatomic distance. This distance to this distance. This is not. Okay, Pritham, how is it possible? How is that possible? So interatomic for Fcc lattice, NaCl is Fcc lattice, right? So for Fcc lattice, this should be this one, these two, this one and this one. These two will not touch. So how you cannot calculate this distance? No, you can't say that. Okay, so this actually you have to calculate this 2R. 2R equals to what? You have to calculate. This is actually called interatomic distance. Okay. Now what is the relation? Relation is A root 2 equals to 4R. So from here I have to calculate 2R value. 2R will be A root 2 divided by 2. That is the expression. So put the value of A, you will be getting your expression. So I think I have given you like wrong option over here. Yes. Simple mathematics. I have to apply this. Interatomic distance, this one. Right? Understood or not? Just put it. A root 2. A means 5.8. 5.8 divided by 1.414. 4.10. The correct answer will be coming as 4.10. So I think I have to edit this thing. Or if you are getting any other answer, please tell me. Please tell me if you are getting any other answer. If you are getting any other answer, please tell me. Please tell me if you are getting any other answer. .6. Okay, 5.6 interatomic distance. Okay, what about interatomic distance? You are calculating which value? 5.6 is given this distance, this A. And why you are thinking that this is this one and this one, these two will touch. In case of Fcc lattice, that is NaCl is showing Fcc lattice. Okay, NaCl is showing Fcc lattice, so they don't touch each other. So if they don't touch, how is that possible? That's wrong. So interatomic distance means this distance. Understood? Please if you understood this problem, put the value of A, you will be getting your answer. That will be 4.10. So I have to check this one. This option will not be correct. I think I have written this one wrong. Okay, it will be 4.1. I have written it 1.4 like that. Whatever it is, yeah, it is correct. 4.1 will be correct one. Understood or not? Please tell me. Understood or not? Please tell me. Understood or not? Please. .95. Any other option? Okay, some of you, okay, 3.95. Okay, did I do any mistake in the calculation? If I did, then please tell me. Okay, some of you are saying 2.8, some of you are saying 2.8, 3.95. Okay, why is this amount of confusion is generating? Why confusion is generating? Okay, just give me 30 seconds. I'm just coming back. Okay, I have to open the door. Okay. Okay, you are getting 3 point. Okay, RC plus RA is equal to A by 2 only for NaCl like structures. RC plus RA equals to A by 2. RC by RA. Just 1 second, let me check one thing. The question is asking the interatomic distance. Just let me just give me some time. Let me check this thing. Let me check the lattice structure. Okay, just tell me. Okay. Okay. You are talking about A, interatomic distance, not any other distance. Okay, so you have to calculate interatomic distance, not other distance. Next question. Next question. Next question. Okay, so look at this now. Okay, the same question is there. So I'm for the timing I am ignoring this question, and I'll be coming back with this question. Question number 19. Come back to question number 19. In a simple cubic body center and face centered cubic structure, the ratio of number of atoms will be what? Okay, the number of lattice will be, okay. So some of you are sending me SMS. How can I reply to you right now? I am taking classes, so I can't reply to you. Okay, so please be patient. Okay, cubic, body centered cubic, face centered cubic. 1, 2, 4. Good job. Question number 20. Crystal structure of aluminium is what? Crystal structure of aluminium is what? Anybody can tell me? Anybody? Crystal structure of aluminium. Anybody? Because these kinds of question you may face in your examination. SK. Okay, good job SK. It's FCC. Yeah. So you have to remember it is a memory based question. Okay, memory based question. So now our MCQ questions are done. Now we'll be moving forward to MSQ type questions. First question. Select the correct point or points regarding crystalline solids. Okay, crystalline solids. So first of all, crystalline solids are anisotropic. They having short range order, arranged symmetrically, having no sharp melting point. Which of this following is correct? Is or are correct? Please tell me. Which of the following is or are correct? Which of the following is or are correct? Which of the following is or are correct? Anybody? A. Some of you are saying B, C, D. SK is saying only A. This is a MSQ type question. Don't forget, it is MSQ type question. MSQ. Okay. Cinephile is saying C and D. Okay. Anything else? B, C. Okay. So first of all, how can you say that it is showing short range order? Crystalline solids don't show any kind of short range order. Even there is no sharp melting point. It is also wrong. Yes, crystalline solids, crystalline, it does have the sharp melting points. It does have. Okay, so it's wrong. Arranged symmetrically, it's right. So how can you say that it is not? It is wrong. Yes, crystalline solid is arranged. Crystalline solid arranged symmetrically. Yes. And what about this? These are anisotropic. Yes, it is true. So in this way, option A and option C becomes correct only, not A, C, D. How D can be correct? It is crystalline solid. You know, you just Google it. What is the melting point of NaCl, KCl, CSCl? You will be getting one value. You won't get like in between 1000 to in between 2000. You won't get that. You will be getting only 1250 like that. In these kinds of value you will be getting. Okay, so you have to look at this problem. So before giving answer, please look at the problem. So option A and option C, they will be correct. Next question. Which of the following pair is or are not? Okay, look at the word not isomorphous. Not isomorphous. Which of the following are not, is or are not isomorphous? Isomorphous. Which of the following? Anybody? These one. Which pair? I am telling you, it is a MSQ type question. So in most of the cases, you will be getting more than one answer. Okay, you will be getting more than one answer. So which one? A, C, D. Okay, it's not correct. Not isomorphous. Not isomorphous. So not isomorphous will be B and C. So NaNO3, KNO3. Why is that? Here you are having Na plus and K plus. There are size differences. Size differences will not work. If you have seen my video on isomorphism in solid state chemistry, I hope you will be understanding that. Please check my YouTube channel. You will be getting the video on solid state chemistry. There I have discussed about this. So B and C. Here you have Na plus and Ca2, calcium 2 plus. Not comparable. NO3 minus, CO3 2 minus. Not comparable. So B will be A and D will be right one. A and D will be right one. So these B and C will be your non-isomorphous system. Not isomorphous. Look at this. B and C. KNO3, KClO3. So a lot of things are there. A lot of conditions are there to become isomorphous. Okay. So please check my YouTube video on solid state chemistry. You will be getting idea, and you will be getting all the examples as well. Okay. So first of all, size differences. Not only size, melting point differences, then boiling point differences, crystallization probability, a lot of things are there. Okay, so you have to take care of everything. Question number 22. So B and C will be your correct one. Yes, perfect in this question. Now next question, which of the following, look at this, which of the following is correct regarding lattice energy? So I will expect that you will be giving me correct answer for this. I will expect that. Which of the following is correct, is okay, is or are correct? It's MSQ type questions. I would expect that you will be giving me the correct answer. Which of the following is or are correct regarding lattice energy? Which of the following? Yes, chemistry of with A's, you are going a little bit slow, so you are right. Which of the following is or are correct regarding lattice energy? B, C, D. Okay, first of all, this is wrong because lattice energy is not true for covalent compound. It depends upon the charge density of cation and anion. Okay, charge density, yes or no? Then the term is relevant to ionic solids. Here it is correct. Then this can be determined through bond length equation but not Born-Haber cycle. It is wrong. You can determine your lattice energy from Born-Haber cycle as well. So how can you say this is wrong? So option B and option C, these two will be correct one only. Only option B and C will be correct one. D is not correct because you can determine your lattice energy from bond length equation and from Born-Haber cycle. Okay. Question number 24. Look at this. The angles present in the hexagonal crystal system. Which angles? Yes, SK. Anybody? A, B, C, D. Which angles are there in the hexagonal crystal system? Hexagonal means HCP and like HCP, hexagonal crystal. AC. Very good. Pritham, good job. This will be 90 degree and this. How it is possible? Let me show you. Hexagonal means this kind of lattice points, right? Here, 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 here. So this angle is 120 degree. Then on this, above this one, you will be getting another plane like this. So this angle is what? This angle is actually 90 degree, right? So 90 degree and 120 degree. Good. Next, look at this. Choose the correct statement for the diamond lattice. Anybody can tell me the right answer for correct answer for diamond lattice? Anybody for diamond lattice? AC. Anybody? AC, ABC. Yes, the correct answer is A, B and C, not AC, A, B, C. Prayojit, you are absolutely right. Prayojit, why you deleted your comment? You are absolutely right. It's A, B, C, not only A, B. Okay, so actually you can't understand this lattice. Okay, you can't understand your lattice, but yes, because if I draw the diamond lattice, you will be like getting confused. So I am not drawing the diamond lattice, but yeah, you have to remember all this information regarding diamond lattice. So what you can do, you just need to understand like all the informations regarding diamond lattice. So whatever information present regarding diamond lattice that I have shared on in my study material and also in my video lecture. So please check the video lecture that is present on YouTube on solid state chemistry. So you will be getting it. A, B, C will be your correct answer. Okay, for diamond lattice. Next. Okay, actually I have repeated this question. The Born exponent of Cstl, it is 9. I have already told you. Okay, question number 26. It is NAT type questions. Look at this. It is NAT type questions. So the Born exponent for Cstl is 9. Then what about this? CaF2. In CaF2, the coordination number of F minus will be what? Anybody? Prayojit, Good. 4. So CaF2 has, if you don't know, CaF2 has fluoride structure. Fluoride structure. And fluoride structure and F minus has coordination number 4. That means 4 calcium 2 plus, 4 calcium 2 plus will surround 1 F minus. Okay, so that's how fluoride structure works. I discussed this in my video lecture in solid state chemistry. Next, with the intercepts infinity, b infinity along x, y and z axis respectively, the Miller indices will be what? So I am giving you the intercepts value infinity, b infinity. Okay, what will be the Miller indices? What will be the Miller indices? What will be the Miller indices? It's quite simple. Just divide it. So this is a value infinity into a. So infinity a, then b, then infinity c. And these are your intercept value. How can you get Miller indices? Simple. A, b, c. These will be Miller indices. So here from here you will be getting 1 by infinity, 1 by infinity. That is 0, 1, 0. So without using comma you have to represent your Miller indices. So 0, 1, 0. Good, Pritam, Yashmin, okay, and Prajit. Good. 0, 1, 0. So for this question answer will be 0, 1, 0. Right? Next. For Fcc lattice the coordination number will be what? For Fcc lattice, what will be the coordination number? What will be the coordination number? Anybody? Anybody can tell me what will be the coordination number for Fcc lattice? Okay, good. Sakthi. Okay, it's a weird name. Pritam, Prayajit. Good. So it will be 12. It will be 12. Yes. Now, last question of this last numerical type questions. So I am asking for the longest wavelength. This question is very interesting. Longest wavelength of X-ray that may be used to determine a lattice spacing of 1 Armstrong by the Bragg's reflection method is this. So you have to calculate the longest wavelength in Armstrong. So you know the formula already, that n lambda equals to 2d sine theta. So what information, this equation, this Bragg's equation you have to use. Now what information I have given to you? Only spacing, I mean d value I have given you 1 Armstrong. But you don't know n, you don't know theta. How can you calculate lambda? But I have given you that the longest wavelength. So for longest wavelength, remember, for longest wavelength for this world, for longest wavelength, what happens? Theta becomes 90 degree and order becomes 1. Put this value, you will be getting lambda equals to 2 Armstrong. Simple. That's the thing. Okay. Yes, Prayajit. Yeah. Lambda becomes 2 Armstrong. So that's all about these 30 questions on MCQ, MSQ and NAT type questions. Okay, fine. So yeah, for the time being, bye bye. Meet you in the next video with another chapter. Okay, so for the time being, goodbye to all of you. I hope this video will help you to practice a little bit interesting questions. Some of you did well, really well, but some of you just watching the videos, watching the questions. But please read the chapter carefully, otherwise you can't solve this kind of questions. And even in IIT JAM examination, if you check previous year question papers, you will be having same kinds of questions. Not too tough, not too easy, medium type questions. Fine. So bye bye. What about next chapter? Next chapter will be your, I think, thermodynamics. Okay. Yeah. Bye bye. Meet you soon. Goodbye.